Hey everyone, it's Steve Goodwin with Anchor Test video number 123. I'm here alongside the Fishing Vessel CAPE CLEARE. She is 70 feet on deck and weighs about 80 tons. And her anchor is this 350-pound Forfjord, and that's going to be the subject of this video. We're going to look at some straight line resistance check with the winch in the sandy mud. Now, these anchors are known to not produce nearly as much holding power as more modern anchors, but they remain very popular amongst the West Coast fishing fleet. That's the west coast of North America all the way up to Alaska. The fishermen stick with these anchors for perhaps a couple reasons. Mainly, the boats that are fishing those waters often have a side hawse pipe, and to stow an anchor, it pretty much has to be a pivoting fluke style. That's one reason, but another important one is out on the outside of the islands in exposed areas, they often will seek shelter and hunker down in strong winds, and the bottom will be comprised of boulders or jumbled rock. And you need an anchor that is very robust, and that is indeed what this is. The more modern style anchors with thinner flukes and other appendages will easily bend, where these anchors might survive a bad entanglement. But in any event, I wanted to put some numbers to it and see just what the holding power is for this anchor. You have seen my testing, perhaps, of the Forfjord anchor that I own. It's only 65 pounds. And when we're done with this test, I'll go ahead and show you clips from that early 65-pound Forfjord testing, and we'll make some comparisons. Okay, let's get to it. This boat is heavy.
Yeah, it's a little more than a dinghy.
But we knew that.
It'll be nice to find out when you do it.
Okay. So I've got the dead man anchor out that way, several hundred feet, and I've got a winch in here, and I'm pulling in on the dead man road. So I'm gonna just slowly winch you that way, but I'm gonna go just little increments because you have so much mass. I need to wait for you to catch up. So this will be slow, but easy. All I gotta do is press a button. There's 800 pounds of pull, just so you know, but we're not there yet. Now we're starting to do something. Oh, 1,600 pounds. Okay, there's a steady 2,000 right now, 2,000 pounds. Okay, I don't know if you can see it, but the catenary is pretty well out of the big boat's chain. There's just going to be a couple more feet of catenary pull that direction. So I've got another 24 feet of pull. So certainly if I can pull that in, we are dragging that anchor. So let's see what happens. 1,800, 1,900, 2,000, 2,200, 2,400, 2,500, 2,600, 27, 28, 29, 3,000. 32, 33, 27, 26, 25, 24, 23, 21, 22, 23, 24, 25, 26, 27, 28, I ran out of segments on that end, so I took up a segment on this end. So we've got 15 more feet to pull it, and it peaked already. Peaked at 30 something, and then it went down into the 2s.
Probably not go up beyond 3,000 again.
Well, we've only got 15 more feet to see, but I would be very surprised if it reached that peak again. It probably pulled out, rolled out. Maybe it'll reset, but...
We need lunch here for a couple of days tonight.
Maybe. 27, 28, 25, 24, 23, 22, 21, 2000, 19, 18, 2000, 19, 18, 17, 18, 19, 2, 21, 22, 23, 24. We need to do one more thing. I need to verify that the dead man isn't dragging. And I have the ticket for that.
So you can just watch that one kind of for feel.
Exactly. I just bring it back here. And if this goes slack, means you're dragging. It stays tight. That means I'm dragging. Doesn't need much slack. I mean, there it is. It's got a little bit of tightness. So we will know. 18, 19, 2000, 21, 22, 23, 24, 25, 26, 27, 28, 26, 25, 24, 23, 22, 21, 2, 21, 2, 19, 2. Here's your proof.
You bring the divers up. How's it going, boss?
Perfect. We are free.
And did you?
It was a show, Steve. Nice to meet you.
Well, it was almost a shit show,
Yeah.
but it was definitely a show.
But that's cool because you didn't let off. You were super animated, and I gotta talk to you about what exactly it is that you're doing and why you're doing it. I don't know
Boy.
how much you can tell me about how, but
I'll tell you what, I'll tell you what I'm doing, and then you tell me why I'm doing it.
okay. All right. We are pretty good at that. Okay, sure.
That could not have come up better.
Pretty good, other than it'll tend to get stuck right there a little bit.
Perfect.
Wow.
Absolutely perfect.
Hey, that's pretty
That's
nice.
so cool.
You want me to hose that off?
Got a hose?
Hang on. I got this. I'm trying to film, hose, and operate a boat all at once.
Great, thank you.
Okay, let's go back in time. This is footage from 2015. This is a 65-pound Forfjord Anchor, and at the time I did not have any winch testing capability. Fortunately, Panopé's boat thrust was adequate for exploring this anchor's maximum holding power in this sandy mud seabed. Incidentally, we're only within a couple hundred yards of the 350 Forfjord tests that occurred 6 years later, so it's good apples to apples comparison here. One thing about these pivoting fluke, widely splayed type anchors is they land perfectly horizontal, and even if you pull on them in a direction, different from where they're pointing, they just pivot around nicely and stay level, and the initial part of the set remains perfectly level. The problem with these anchors is that they do not dive. Some people strongly correlate holding power, or I should say some people attempt to strongly correlate holding power with fluke area. And indeed, these anchors have small flukes for their weight. But I believe an equally or perhaps more important factor is the ability of the anchor to dive into the seabed. And these anchors do not have that. There's probably several reasons why they don't dive, but a big one is that big, wide, square shank just is difficult for the anchor to drag downward into the seabed. And those two flukes are quite wide from each other, and if one fluke was just a little bit, maybe holding a little more, the anchor starts to rotate or twist or roll in the seabed. And as that happens, the fluke tip that is penetrating deeper, it then penetrates into more solid substrate, making it worse, and then the roll just gets worse and worse. I think of it like a teeter-totter, with the shank as the fulcrum, and two kids are the two fluke halves, and the one half is just heavier. You got the heavy kid going down and the light kid going up, and like as I said, it gets worse and worse as that better performing side of the anchor digs deeper. Well, the substrate just gets firmer and stronger. So the anchor's just creeping ahead here. We see lots of heaping going on, and soon the fluke that's closest to us is going to emerge from the seabed. There it is, right there. I just can see the point of it sticking up there. I'll stop the footage here so you can take a look at it. That is the fluke, well above the seabed now. The other fluke is going to be pointing more straight down. But at some point, the elasticity of the nylon portion of the rod acts like a rubber band, and it just rips the anchor out of the seabed, and I discontinued the test at that time. We never saw the big 350 release, but we didn't have nearly the sort of dynamic potential. There was no nylon in that rod, it was just chain. That mud on the flukes indicates to me that wide shank or not, the anchor may not be able to dive anyway, because I'm learning that flukes that get plugged up with mud, whatever their shape is, it just changes the way the anchor performs, and it's always for the worse. Okay, this is a different set. We're looking straight down on the anchor, and as we saw, the anchor slowly just penetrates into the seabed within an anchor length, which is just great. This was a direction of pull change. It's one of my 180-degree resets, but this was one of my first attempts at this test, and I really hadn't developed my technique very well, and it wasn't really 180 degrees. It was probably more like a 160-degree direction of change. But in any event, this anchor negotiated it perfectly. It just spun right around and stayed nice and level. The caveat, though, is that it wasn't pulling very hard. It wasn't even near this anchor's fairly low maximum holding. Okay, before we look at some numbers and comparisons to other anchors, I'll mention that I only gave the 350-pound Forfjord one and only one winch pull. And normally I like to see a few more samples before I start relying on data. However, the owner of the Cape Clear has done a few test anchorage with his setup now, and on one occasion he anchored just about a half mile down the beach in 20 knots of wind, and he did everything carefully, set the anchor properly, and sure enough the boat was dragging, again, 20 knots of wind in a very similar seabed. So based on that, my winch test, and my previous testing of my Forfjord anchor, I just have no reason to believe that our winch test that we saw today was a good, clean, reasonable expectation of what you would get out of that anchor. So let's get to some numbers. First, here's a Mantis dinghy anchor. Did an incredible job with it one time. It held about 600 pounds. It was just creeping forward, eventually bent the roll bar, but 600 pounds of holding with a 3¼ pound anchor. That turns out to be 185 units of holding per anchor weight unit. And that was with 12 feet of chain at 5:1 scope. This Fortress FX23, which weighs 15 pounds, I recorded a max winch resistance of 2,400 pounds for a ratio of 160 units of holding per anchor unit weight. That was with 12 feet of chain at 6:1 scope. A Mantis M2 45 pound, it had a max winch of 5,000 pounds, and actually I cut the test off. We don't know what its maximum was because, again, I just stopped going at 5,000 pounds, and that works out to be 111 units of holding. That was with 80 feet of chain at, so what was it? It was 8:1 scope, so it had a pretty good advantage there with more scope and lots of chain. This Quickset 22 with no chain at 5:1 scope, it did 2,000 pounds of winch resistance for a ratio of 91 units of holding per anchor weight. And then we get to the Forfjord anchors. My 65-pound Forfjord, it had a full release at 910 pounds, and if we use that number, we get only 14 units of holding per unit of anchor weight. That was with 80 feet of chain and 5:1 scope. And then if we look at the anchor of the day, the 350-pound Forfjord, it had a max winch resistance of 3,300 pounds, which gives it only 9.4 units of holding per anchor unit. And it did have 180 feet of all chain, real heavy stuff, 9/16 chain, and it was at 6-to-1 scope. So it certainly was a fair fight, but clearly the big Forfjord is the big loser of all the anchors I've tested that were able to set properly. In terms of holding power per anchor weight, absolutely the lowest. Now this brings up the question, maybe anchors do not scale at a 1-to-1 ratio in terms of their holding power over their weight. I've started to dabble in this, but I haven't done a whole lot. You may recall that I've tested 5 different Bruce anchors over in the soft mud, and I found that with the exception of the smallest Bruce that I have, which is only 11 pounds, the rest of the anchors tended to be about a 1-to-1 ratio, meaning if you doubled the weight of the anchor, you'd get about double the holding power. Now, other people's studies have suggested that maybe the number is not quite 1. Maybe it is more like 0.8 or 0.9. But, frankly, I don't squibble too much about 10 or 20% one way or the other. I'm looking more for orders of magnitude differences in my testing, or at least doubling. That to me, when something is twice as good, now that's something we can generally kind of rely on. And indeed, an order of magnitude does seem to be the difference in holding power between the old Forfjord anchors and the better modern anchors in that sandy mud seabed. So yeah, at least 10 times better performance for the new anchors. Okay, that's all I got for the Forfjord anchor testing for now. Thanks a lot for all the interest and donations to my anchor studies. We'll see you next time. So long.